Hello to all my IM1 classes at Prospect High School. I hope you guys are all figuring out how to behave yourselves and stay socially distant as necessary during these difficult times. We're going to try to do classes online, and this is my first attempt at making a class for you that you will be seeing and learning about a new topic in Unit 8. We're going to be talking about midpoint formula and distance formula to get started with. So hang on and we'll make that happen. So in this lesson, we're in Unit 8, which is dedicated to midpoint and distance formulas to start with. So as we get into this, let me start to describe to you about the midpoint formula. So if we just start with a number line and identify that this is maybe 2 and that this is maybe 12 on the number line, we can actually calculate a point between 2 and 12 that is equidistant from 2 and 12. So meaning that that distance right there is going to be the same as that distance right there. Well, calculating it is actually very simple. It's really just taking the average of the two coordinates of the line. So here we go. We're just going to say 2 plus 12, and we divide that result by 2. So 2 plus 12 is, sorry about that. So 2 plus 12 is 14, and we divide that by 2, and we get 7. So the coordinate between 2 and 12 is 7. And if you think about it, 7 is 5 units away from 2, and 7 is 5 units away from 12. So that makes then 7 the midpoint of the segment with endpoints 2 and 12. So that's just a very simple illustration of where we go when we actually do this now on um, a coordinate plane. So let's do this. Let's take the points -4, -2, and let's see, -4, -2. And let's take another point, let's call it 6, 6. Let's just do that. And we have those 2 points right there, and we want to find that point which is right in between. So let's see, this is got the coordinates 6, 6. And so what I want you to understand is that as we're looking at this, we're looking at a vertical component. And if you look at the vertical component, it's that long. And if we look at the horizontal component is this long right here. And if you really look at the endpoints of those components, we have in one case here, this point is 6, -2. And here's what I want you to see. Notice that in the vertical component, the y-coordinate is 6 and the y-coordinate is -2. So if that's the case, then I can actually take the midpoint of this segment right here and find it. So let's just do that. We're going to say 6 plus -2 and divide that result by 2. So 6 plus -2, that's 4. Divide by 2, that's 2. So here we are at a height of 2. And so there's that. And then let's take a look at it from the horizontal standpoint. So here we are, we're looking at this right now. We're looking at coordinates of -4 and 6. So we can add those together. -4 plus 6 and divide that by 2. And we get -4 plus 6 is 2. 2 over 2 is 1. And so that makes this point right here the midpoint of that horizontal line. Well, now if we take those two coordinates and converge them to the point that's on the line that we're trying to find the midpoint on, then now we have the coordinates of our midpoint of that segment. So here we are at an x value of 1, comma, and a y value of 2. And that makes 1, comma 2 the midpoint of this line segment right here. So that's saying that that distance right there is the same as that distance right there. Now let's just see what I really did. Didn't I just do this? I took really the difference, or not the difference, but the sum of the x coordinates, x1 plus x2, and I divided that by 2 in order to find the average of those two. And I also took the sum of the y coordinates. So y1 plus y2 and divided that by 2. Now let's see where that happened. So here we have let's see, I'm going to make an arrow and just move it around to show you some things here. Okay, so we've got my y coordinates divided by 2, and that's what gave me the 2, and there's the 2 right there. And that was done by looking at y1 plus y2 over 2. Let's look at the x coordinates. Well, the x coordinates were -4 and 6, and when I added those together, I got 2 and divided that by 2, and that's what gave me this part of the midpoint formula there. So if I then add those two together, we ended up with something that looked like this. -4 plus 6 divided by 2, comma, 6 plus -2 divided by 2. And that gave us 2 over 2, comma, 4 over 2. And that came down to 1, which is 2 over 2, and 2 as my midpoint coordinate. So in summary for the midpoint formula simply is the midpoint is equal to x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. That's the midpoint formula. You may have seen that before, but I just wanted to make sure that I taught that clearly. All right. So now the next thing to do is to talk about the distance formula. So now the distance formula, we're just going to take those same two coordinates. We'll start from 2 and go from 12. And we know that the distance from 2 to 12 is 10, but let's look at that mathematically. In order to find that, can't I just take, if I called this x1 and x2, I could just say x2 minus x1, or 12 minus 2, is equal to 10. And so therefore, the distance from 2 to 12 is 10 units. So there we can do that with distance formula. Now, this becomes a little bit more complicated as we describe the formula for distance, but let's just take a look at this on a coordinate plane. So we'll do this. Let's take the distance between, and we'll go -4, -3. How's that? So -4, -3. And we'll do the distance between that and 2 and 6. 2 and 6. So meaning I want to know how far then between this point and this point right here. Okay? So that's what we're going to do, and we're going to use the distance formula. But before we do that, let me develop it for you. If I draw the vertical and the horizontal again, so I'm going to go from here to draw the vertical, and I'm going to go draw from here to draw the horizontal. Don't I have a right triangle? with the horizontal and the vertical portions being the legs of the right triangle. Well, doesn't Pythagoras tell us if we called this side A and we called this side B and we called this side C, that C, the length of C, is the distance between the 2 points. So Pythagoras then tells us that C squared then is equal to A squared plus B squared. So isn't this true then? That I could say the square root of C squared and the square root of the sum of those squares ends up being that the length of C ends up being the square root of A squared plus B squared. Well, A is the difference between the x's. B is the difference between the y's. So let's look at it using a formula. Right now what I'm looking at is C is equal to the square root of A squared plus B squared. But isn't A the difference of the x's? So I'm just going to call that x2 minus x1. And I'm going to square that. So that squared comes from the A squared, right? And so then this is going to be B, the length of B. Well, that's just the difference of the y's. So I'm going to say y2 minus y1 squared. And we're just going to take the square root of the whole thing. And so now you see that there's my A right there, and there's my B. And when I take the square root of the differences squared, then I get the length of C, or I get the length between those two things. So let's just do this for real now. We're going to say that length of C then is going to be x2, which is 2, minus -4, that squared, plus y2, which is 6, minus -3. And that difference squared. All right, 2 minus -4 minus negative is plus, so 2 plus 4 is 6, so that becomes 6 squared plus, and 6 minus -3 minus negative is plus, so 6 plus 3 is 9, and that's squared, and we're taking the square root of those two. So C is equal to 6 squared plus 9 squared in this problem, and 6 squared is 36, and 9 squared is 81. Let's see, 36 and 81 gives me a 7 there, and 3 plus 8 is 117. So the square root of 117 is the exact answer that gives me the distance from C, from -4, -3 to 2, 6. And that's the distance formula. And in this case right here, and I'm not thinking about whether that is simplified or not, but the exact answer then becomes the square root of 117. So to summarize what we have then for midpoint formula and for distance formula, we'll just go ahead and say it this way, that the midpoint between any 2 points, x1, y1, and x2, y2, on the coordinate plane can be calculated using midpoint is equal to the sum of x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, and that gives you the coordinates of the point that we can call now midpoint. And then the distance formula, the distance between any 2 points made up from the coordinates x1, y1 and x2, y2 on the coordinate plane, can be calculated by using distance equals the square root of the difference between, x2 and x1 squared plus the difference of y2 minus y1 squared. So that's what we want to say. Let me just say it again. Distance is equal to then the square root of the difference of x2 and x1, so x2 minus x1, that difference squared, plus the difference of y2 and y1, or y2 minus y1, that difference squared. So when I add those two differences squared together and then take the square root, I have the distance between those 2 points.